Hello everyone. So let's come to the next discussions. So in the previous video, we were discussing about the arcing ground phenomena. Now we will discuss how to avoid this particular phenomena. Okay. So to avoid this arcing ground phenomena, as I mentioned in the previous video, we use basically Peterson coil. Basically, it is a nothing but an inductor, variable inductor. And we call it as a resonant coil also. So to understand this particular scenario, how to avoid it, it is always better to go with the phasor analysis. Okay. So let me draw the phasors for the three phase of the generators. Let's say this is my A phase, this is my B phase, this is my C phase. Okay, A phase, B phase, C phase. Okay, they are displaced at 120 degree. So this is my E at an angle 0, E at an angle of minus 120 degree, E at an angle of 120 degree. Okay, and we also observed like the VB voltage, it is root 3e at an angle of minus 150 degrees. So this is your minus 120 degrees. So your phase the B voltage will simply be located at here. This is your VB, and that magnitude will be root 3 times of the E, and this angle is basically minus 150 degree. Okay, so this is the case. Now if you see the C phase voltage, the C phase voltage at simply just it is look at 150 degree. So it will become like this, VC, and this angle is basically 150 degree. Okay, that's it. So this is the phases. So you can see here your B and C phase voltage has increased by the root 3 times magnitude wise. And if you draw the fault current was basically IF is equals to IF is equals to it was phasor summation of IB plus IC. And what was the location of the IB and IC? IC at 120 degree, IB at 120 degree, and IC at 60 degree. Okay, so this was my 120 degree, this was my 120 degree. So this is my, you can say, IB, and my IC was at 60 degree, right? So 60 degree will be somewhere here. So this is my IB and IC. So this is my IB, and this particular one is basically my IC, you can say. So if you take the resultant current, the fault current, it is located at 90 degree location. So this is my 90 degree with, because this is my reference. So all angle will be calculated from this particular reference. Okay. So the current, this is the phasor sum. So this is your fault current, you can say, and it is basically IB plus IC, and this was your IB, right? And this was your IC. So you can also observe here the capacitor behavior. Capacitor, in case of capacitor, basically the voltage leads the current, but voltage lags the current by 90 degree. So, but if you see here, I have taken the opposite notation. So here I have the plus, I have the minus, where I have the plus and I have the minus. So if you see this B phase voltage, and if you take current in this direction, then your voltage will lag, but I have taken the opposite direction of this particular current, so the scenario will be opposite. So here you can see, if you see this particular IB current and this particular voltage, here your VB voltage is simply leading, but it is because I have considered the IB direction in opposite direction, but actually your IB is located at at this particular location. So in this case, if you see, if your phasors are rotating in anticlockwise direction, your voltage will simply lag by 90 degree. But since I have taken the opposite direction, that's why the scenario will be entirely opposite. Now my aim should be, this particular fault current was responsible for the arcing, repetitive arcing. So if I can eliminate this particular current, so that then our job will be done. So let's say I'm able to produce a current that is in this direction, same magnitude and all. Okay, let's say this is my current, and I'm calling this current as a I prime. Okay, and my phasors are rotating in anti-clockwise directions. Now, what should be the nature of this I prime current? This that should be the inductor, right? Because the lagging of this voltage and current, and voltage leads the current, you can say. So it is 90 degrees, so it should be inductor. So if I place an inductor here, let's say if I inductor here, and this is my I prime, okay? Take the KVL, this is my plus and minus. So I prime j omega L minus and plus E at an angle of 0. So if you calculate from here, your I prime will simply become uh, E by j omega L. Okay. So this is your you can say I prime. So if you take the phasor, this j at the numerator, so it will become minus 90 degree. So by having a inductor, you can basically you can nullify this particular fault current that was creating the arcing. So this particular current I prime is simply nothing but an inductor current that will flow through the Peterson coil. Basically, this particular inductor, it is a variable in nature. Depending on the capacitor, we have to fix the value, and we call it as a Peterson coil. Okay. So this particular inductor, right, by varying the beacons of the core material and all, we can vary the inductors of this inductor, and you can nullify the arcing ground phenomena. Okay. In that case, this if from the phasor summation you can see that this inductor current will completely nullify this if, so there will be no arcing ground phenomenon. Okay, so this is how we have to avoid it. I hope it is clear, but still if you have any doubt you can ask me in the comment section. Thank you.